such researches, he and his colleagues utilized the technology of TDS in their exploration of the source of animal cell electricity. And currently more than 50,000 sessions of TDS have been used all over the world. And I was glad to be a participant in 2 or 3 such sessions. As you all know, the neuromodulation techniques has been used throughout the history of psychiatry. For example, we have the classical electroconvulsive therapy, which is the ST, and currently we do use the transcranial magnetic stimulation. All such techniques use the AC current. The only method that uses the DC current is the TDCS. We have new researches in Europe and America about the spinal cord stimulation and also about the left vagal nerve stimulation. It's a kind of, pioneer investigation that will, I think, cause a breakthrough in the management of psychiatric illnesses. Now, this is a brief history of the electrical stimulation. The ancient civilizations applied the torpedo fish to the head to treat certain illnesses. They assumed that there's an extra electricity in the brain of clients who suffered from mental illnesses, so they used the torpedo fish in order to get that electricity out of the brain. In the 19th century, Aldini used the electrical stimulation for both live and corpses, live clients and corpses, in order to stimulate certain muscular entities in the body, and they've stimulated the brain for the management of, let's say, depressive clients with major depressive disorder, and such researchers were only treated the major depressive disorder. After that, there was a kind of, let's say, expansion in the researches of the electrical stimulation. Now, in the 20th century, the electric sleep therapy was initiated by our Russian colleagues. Then the brain polarization in the 1970s, and in 2000, the TDCS. If we can see on the graph, there is a lot of studies about the TDCS. In 2012, it was around 200 studies, and now a new phase of the researches from 2012 to now will be released soon. Now, the legal status of the TDCS currently allowed in the European Union, Australia, Brazil, and Singapore. In the United States, still investigations under the FDA regulations. Doctors in the United States are allowed to provide off-label treatment of the TDCS, and of course, anyone can order the TDCS machine via the Amazon. The mechanism of action of the TDCS, actually, we have a low intensity current, almost 1 to 3 milliampere, that pass through 2 electrodes placed over the head. So we have either the bipolar presentation or the unipolar presentation. In the bipolar presentation, we apply 2 electrodes. One is the anode, which is the positive stimulation, and the other is the cathode, which is the negative stimulation. And both bipolar, and that bipolar presentation is the most commonly used presentation, actually, to treat major depressive disorder. So either we use, as I said, the bipolar, where we apply 1 electrode or 1 anode or cathode to the skull, and the other reference electrode is usually applied on the upper limb. Of course, in comparison, for example, the ECT, which uses 800 milliampere, we usually reduce the impedance, which is a crucial factor in the compliance for the TDCS. And as you all know, according to the Ohm law, the power equals the energy over the impedance. So if we reduce the impedance, there will be no loss of the 3 small milliamperes that we usually use in the TDCS stimulation. Now, we say that TDCS stimulation, the transcranial direct current stimulation, actually it's not a stimulation per se, it's a kind of polarization. So we usually change the electrical environment of a brain rather than initiating an action potential, which is in comparison to other neuromodulation techniques. So the electrodes are usually placed according to the national 10 or 2020 EEG system. Now we use the neuronavigation techniques, which is used in neurosurgery in order to allocate the areas of interference. The neural navigation techniques are currently very smart techniques, and it's available almost to everyone. We have 2, as I said before, we have 2 poles, the anodal stimulation that excites the neuronal activity and the cathodal stimulations that inhibit the neuronal activity. When positive stimulation, which is the anodal TDCS, is delivered, the current usually causes depolarization of the resting membrane potential. Depolarization is a hyperpolarization, which means that we change the interior of the cell into more positive environment. That will cause stimulation of the membrane potential, and that will cause subthreshold action potential. It's not an action potential like that we see during the transcranial magnetic stimulation or other neuromodulation techniques. Also, when we apply the negative, the cathodal TDCS, the current causes hyperpolarization of the resting membrane potential, and that will decrease the neuronal excitability. And we have also the sham control, which is the control, which is the reference. And in the sham, we usually, the clients receive TDS, and they do not know that they are not receiving that stimulation. So if we compare the results between the anodal or the cathodal and the sham type of this stimulation, all that based on the montage that we use, we can say that the TDS actually, the effect of the TDCS is caused by current stimulation rather than by placebo effect. That applies to the clients under the sham stimulation. So the traditional unihemispheric or unipolar TDS setup, one electrode is known as the target electrode with the cathodal or nodal, and the other one is the reference electrode. So this is the classical TDCS. If we see the red one is the anodal stimulation, you put more energy to the brain, so you change the electrical environment of the brain. You usually, let's say, polarize the area, the targeted area using the neuronavigation techniques. And the other side is the cathodal, where the electricity exits from the brain. So we stimulate one part, and as you all know, the brain is not a flat surface. So in each gyri, you may see one stimulation of the one side of the gyri, and you will see a kind of depolarization of one part of the gyri and hyperpolarization of the other part of the gyri. So by such, we usually, for example, we depolarize the soma and we hyperpolarize the dendrites. By such, we change the electrical environment of the brain, and by such, we change the functionality of the brain. And as you all know, there is a high connection and interaction between the electricity and the blood perfusion, oxygen consumption, as well as the O2 consumption and glucose and blood perfusion in certain areas of the brain. For example, in major depressive disorder, we usually apply the anode to the left dorsolateral prefrontal cortex, and we usually apply the cathode on the upper limb. So here we depolarize the soma and we hyperpolarize the dendrites. This is the classical illustration of the TDCS kit. As you see, we have a cap, we have a depolarization gel, we have the batteries, we have the charging device, and we have also the normal saline where we used to put the electrodes. So now we have two different montages of the transcranial direct current stimulation. We have the online design and the offline design. In the online design, we usually give the clients tasks to perform under the stimulation. So by such, we can measure the behavioral change that occur to clients under stimulation. And we have the offline design. By the offline design, we usually do not use any active parts or active participation of the client. Saying so, it means that the client either finished the task before or after the stimulation. And the most commonly used one is the online design. At home, we usually use the offline design. So clients can take their TDCS device and they can go home. And we can monitor the response based on our interaction with our clients. So when the electrodes are placed in the region of interest, the current induces intracerebral current flow. This means that we change the blood perfusion in the selected area, and this current usually flow, they either increase or decrease the neuronal excitability, as we said, the cathodal or the nodal stimulation. And the change of the neural excitability or the neuronal excitability generally leads to alteration of the brain function, which can be used in various therapies as well as to provide more information about the functionality of the human brain. So for example, in case of treating major depressive disorder, TDCS currently target the left side of the dorsolateral prefrontal cortex, and we can allocate that using the neuronavigation techniques generally. For example, other clinical indications for the TDCS in addiction in alcohol spectrum disorder, and neuromodulation aims at craving, reducing the craving, the consumption, and the other physiological and pathophysiological, let's say, manifestations like the impulsivity and executive functions generally. In schizophrenia, negative symptoms and also positive symptoms are targeted. We also use it in epilepsy. As we know, we have two types of epilepsy, either focal epilepsy, and usually the temporal lobes, the mesial part of the temporal lobes are almost always accused of having the major portion of induction of the epilepsy. So we either wait until the fit or after the fit. We usually stimulate the temporal lobes, because after the fits, as you all know, there is a hypoperfusion of the blood and we have reduced oxygen in targeted area. In the generalized epilepsy, we can see that the whole cortex is accused of causing that epilepsy, and as we all know, there is a high interaction between temporal lobe epilepsy and depression. So we may also target the left side of the dorsolateral prefrontal cortex after the epileptic fit. And epilepsy is also a contraindication, relative contraindication to TDCS, because according to the observations, transcranial magnetic stimulations and TDCS induced a kind of focal fix in some clients. The classical and the most investigated part also is the use of TDCS in major depressive disorder. And according to the meta-studies, I will show 2 or 3 studies at the end of this presentation. They showed that there's more than 34% improvement in the active symptom stage. In borderline personality disorder, TDCS is so superior on core dimensions, for example, on the executive functions, emotional dysregulation, and impulsivity and aggression that characterize the borderline personality disorder. In attention deficit hyperactivity disorder, there has been a lot of researchers using the TDCS in working on the behavioral manifestations of ADHD, especially the inattentiveness and the impulsivity, by stimulating or reducing the stimulation of certain selective brain areas. Now, in obsessive compulsive disorders, as we said, in case of major depressive disorder, we usually stimulate, or we usually, let's say, do a galvanic stimulation for the left dorsolateral prefrontal cortex. In OCD, we do such stimulation to the dorsolateral prefrontal striatal cortex, actually, and that circuit is involved in the formation of obsessive compulsive symptoms. Some clients are refusing medications, so we usually do the TDCS based on a client's preference. In post-stroke aphasia, and has been a lot of researches about the use of TDCS in stimulating the brain after stroke or after even transient ischemic attacks. The language functions have been improved dramatically after using the TDCS stimulations. And in generalized anxiety disorder, as you all know, there is a kind of disconnection between the areas that is involved in emotional regulations and the amygdala. So if we can stimulate actually the blood perfusion around such areas, we saw and researchers conducted that there is a kind of reduction in the panic pattern or the anxiety pattern that is characterizing the generalized anxiety disorder symptoms. Also, we use the TDCS, or there has been some researches on the TDCS for Parkinson's disease, chronic pain, and autism also. Improve the delay of the syntax acquisition in autistic spectrum disorder. Also in case of senile dementia, Alzheimer dementia, vascular dementia was a contraindication. Also in cases of traumatic brain injury and fibromyalgia and migraine, and this technique is commonly used by our colleagues, the neurologists. So as we said before, the latest CAN-MATE guidelines and the European guidelines, they've agreed on the usage of TDCS as a treatment for major depressive disorder. It's not a monotherapy, it's add-on therapy. Because, for example, all studies, one of the most important studies actually, it's the last one that compared the use of TDCS alone